Thanks for joining this video, and this tutorial will be a little bit different because we will model something that I already modeled once, and I will just go through the script step by step, explaining what I do so you understand better how bit by bit works in parametric scripting. So we will be modeling this shape that you see in the projects page. It's using variable radius fillets, and it's not a very difficult script itself, like it's not too big. So you can open the script yourself. It's public, it's open source, you can hit run, and when it's finished you see that it's still computing. So this shape uses variable radius fillets and many more algorithms of bit by bit like text and things like that, and you will see in the video how it all is assembled. So let's get started and let's close this whole project. I will just open up the Rete editor from our apps page here, and I will begin coding. So the first thing I did, I created a skybox, and you can do that by clicking the right mouse button and typing skybox, and this will put the component skybox in here, and you can just click city for the environment. And what I like to do is increase this blur effect on the skybox. So you see here now that I'm in 3D space and it looks quite nice. I actually like it even larger. So there are a few skyboxes here, like default is with the clouds. You can see them better maybe when disabling the blur a little. So this is just clouds. This is the clear sky. Yeah, looks quite nice. There's sun there, and I like to use this one especially when I'm modeling metal because it gives me nice reflections and then I can understand better the shape. So we've started now with the skybox. Another thing I usually tend to do is I create the grid, and I can do it by clicking again right mouse button to activate the search and type grid. So this is the component that creates the grid, but you can also do it through this draw button, and you can click here and draw grid. So now the grid gets added, and you see here that we have a nice looking grid which represents the ground plane. And we don't yet have any objects in 3D, but we will, so it is also okay to add a directional light. And I do it by clicking the right mouse button again, and I use intensity that is set to 3. So now we don't see any shadows, but this will activate shadows as well too. And you see that these two components are coming from the Babylon category, and Babylon is the game engine that runs all the visual aspects of bit by bit. So I guess now it's pretty obvious what happens here. Okay, another thing that I do when I start a model, I try to think how my shape will be composed. And you've seen the model that we had. It was a sort of circular shape with some cutouts. So I will do the same now. So I will first create a circle wire. And you see that OpenCascade kernel and OCCT category has algorithms to create various kinds of shapes. So like edges, wires, faces, shells, solids. So how you need to think about those is that edges can be composed into wires, wires can be composed to faces, and of course decomposed to edges, and faces can be composed into shells, and shells can be, if they are closed, composed into solids, and you can compose multiple solids, for example, and well, any other shapes into compound shapes. So these are sort of assemblages of geometry. Okay, so let's get started, and what I want to do is I will create a wire primitive. To do that, you can browse this category and just find the circle under the primitives. And what it does, when you create it, you will see the circle here in your 3D space immediately, and that's just a small wire that we've made. And now I will change its radius to 10 so that it would be larger. And what I will do is I will divide this wire into 10 parts, right? So divide wire This is the function that I'm looking for, and there are more variants of it, but I will just use this one, dot wire by params, and I will say that this is my shape, and I will remove the endpoint so that they don't match, like start point and end point, they are on the same place if you divide it, and we don't want that. So now we have 10 points, and you can also see those points as red dots on your model. So this is quite nice, right? You see them immediately appear in your 3D scene. Another nice thing about this is that you can hide your models by clicking this arrow button and checking hide, and then they disappear. So the points or the circles, they just disappear if you hide them. By default, Rete Editor will draw them to you as long as you don't specify that they should be hidden. Okay, so now we have 10 points, and now what I will do is I will show you how this data looks like in preview. So here we have this preview category. It only has one component as of this tutorial. There might be more later on, of course, but you see that the points are structured in a way that they are sitting in the array, and the point itself is also just an array of 3 numbers, and this is quite handy. What I want to do actually, create a circle face component. And you also have to understand that we always use OpenCascade algorithms with other OpenCascade algorithms. There are ways how to go and transform the things from one kernel into another. But when we work with OpenCascade geometry, we usually tend to just work with these components that are coming from this category. So if you want to transform the circle, you will look for the transformations in here under OpenCascade kernel. Okay, so I've created now a circle, and you see that it's sitting in the center of my circle wire. What I want to do is I want to say to this component that should use the centers that were created here. So you see that this component outputs an array of 0.3 elements. And we also had this preview data component that showed what kind of data we're dealing with. So it's an array of 0.3 elements. And what you can do is you can use that to create multiple circle faces on multiple points, but this center just takes one of them. So what I will do is I will flatten this list. You see now it's flattened by one layer, and what happens if you flatten the list and you pass it to this kind of component, which takes a single element, is that it will run multiple times. This is how bit by bit Rete Editor works. So I will just now try to connect these two, and you'll see that it's impossible. These types still don't match, and bit by bit doesn't know and think that it's impossible to connect the two. For that situation, it is quite rare that this happens, but you can always use pass through component, and that will force the transition. It removes the type. This type is then any, and you can just pass it onto the circle component, and that just creates multiple faces on a big wire, right? It used all those points as its centers. I will just increase the radius of these circles so that they are a bit larger. I will also create a face from the wire that we created initially. So I will do this create face from wire command, and you always see these paths, right? So shape face, create face from wire. You can always go to this OpenCascade shapes face, and then you can find the components here, face from wire. It's exactly the same component. So if you click that button, it comes here into the canvas. Okay, so now I will just connect the two, and voila, we have our set of geometry for the base of the model. What I will do now is I will create a difference between the circles and the original shape. So you see here again we cannot connect the two because this requires the array of shapes. And if you look into the preview date of this component, because we passed it a flattened result, it created also a flat list of shapes, and we just want to increase this into a list. So we will use create list component, and you can just hit it like that, or you can go here into the lists and then find it here, create list. This is exactly the same component. So what I will do is I will copy the preview data, and you will see the difference between those two outputs. So what this create list does is just it takes all the elements and it puts them into a one array. And this array now can be passed into this component as the list of shapes. And what I will also do is I will tell that this face is planar. And now we don't yet see the result, but actually we computed it correctly. It just needs us to hide previous geometry, which now sort of intervenes with what we've got. So let's hide the initial face, and also let's hide these circles, and let's also hide this and this. So now we removed all the points, and we've got this new face that we will use as the basis for our geometry. And this is quite nice, right? Because we just used few components and already got quite a interesting parametric shape. This also is nice because you can always go and increase the number of radius, for example, or you can increase the number of points, so you would get more circles. You can do this. You see how shape reacts, and all the code is running immediately. But let's continue it like we had. So let's keep it on 10 and 10 for divisions and the radius. So another thing that I want to do to the shape is I want to round these edges so that they're not that sharp. And to do that, I'll use the fillet command, but I will try to use it on the wire itself. So I will say that I want to get wire from the shape, and the shape is in this case the face. So I will hide it now. You see that now I've got the wire here, and I will also say that I want to fillet 3D wire. I can actually also use fillet 2D. It's a 2D shape indeed. That might work as well. So I'll say that I want to fillet that, and I'll use the radius of 0.5 for example, and I'll leave that result and hide the wire that was original. And now you see that the sharp edges disappeared, and now we have a nice looking wire, which is quite complex, but still it's parametric, so that's quite nice. So now we can also go ahead and increase the number of our circles, and it's still working. So let's continue using 10. So now again I will create a face from this wire, and see how I can transition freely, right, from intermediate geometry. Sometimes I create the face, sometimes I get the wire, I adjust the wire, and then I transform that to the face again. You can always be smart how you do those things. Some computations are more expensive than others, so you have to keep that in mind, but in general it's quite fast, so just model as you wish. I will say that face from wire is what I want to create, and this is it. It's gonna be a planar face, so let's connect the two. Okay, now this is a better looking face that I like. We can delete these preview components here, and what I will do is, because we're modeling here in the editor, I'll just export this as a file so that the script is saved in case I lose it. Okay, so now we have this outer shape, but I also want to create the inner hole in this face before I make an extrusion. So let's do that. I did it in a similar way. So I will first create the circle again, circle wire. And then I'll just increase the radius to 1.2. I will also use divide wire by params to points command. I'll hit like that. I'll want 5 division points, and I'll hide this face for now so that we better see what we do. And I will create again circle faces on top of these points. I'll use the pass through. And I'll flatten it out. Okay, so now we have nice looking flower here. And what I will do is I will use a difference command again, so between the circles and my face here, and let's do that. So difference, and the shape will be this shape, and I will create a list here. So let's do that. Let's see what the result is. So you see that we still have this in the middle, and that just requires me to increase the radius a little, and now it's gone. So now I have the inner hole on that face, and I will just hide this. I will hide this, and that's it. So now it looks quite okay. This is what I want to extrude. Okay, so we have this difference command now, and what I want to do is I want to extrude this shape, and I will use a vector. So vectors you can also find here. There are various vector commands that you can use in here, but I will just use a vector, and vector is also a point, or it is represented by a point here. So I will use 4, and it's just a direction vector, and I will use that face and extrude it like that. Okay, so this is quite nice, because now we've extruded the whole thing, and it begins to remind us of the final shape that we are creating. You still see here this point, but this is just this vector being visualized, and we can remove it here. So now everything is red. It's a default color of geometries that are created in bit by bit. And now I want to fillet the edges, the outer edges, and to do that I will use some tricks. In order to fillet only these edges with a variable radius fillets, we will need to select those from the list of edges on the wire. And that's quite an interesting operation. So what I will do is I will hide the extrusion for now. I will also hide this difference for now. And I will get the wire, get the first wire of this shape. And I'll move it a bit further because we will be doing some coding later on here. So now we have this wire, and what I want to do is I want to get the edges along the wire. So this is important, to get the edges along the wire, not just edges, because sometimes in OpenCascade they can be ordered in strange orders. In this case it will be ordered in a good way along the wire, and all directions of those edges will also be facing the direction of the wire as well. So now what I will do is I will connect this wire to this. So what happens is that now we have, if you preview this data, so let's preview both the wire and let's preview the edges, you'll see that this contains multiple items, multiple edges in the list. And this just contains one wire, one shape in OpenCascade. And you see this hash is like a address in OpenCascade kernel for the shape, and we use that to communicate with the web worker. It's a bit technical, but you don't see here the object properties or anything you apply various methods on top of these shapes in bit by bit instead of doing sort of object-oriented programming. So here you are, you're doing operations on these shapes, and now you have all the edges, and what we want to do is we want to filter out only the edges that are these ones. And for that we will use a nice list command called pattern. So you can always just click right button and click pattern. So you see here get by pattern. So patterns are nice ones because you can just define the pattern how you want to filter out the items, and it's a Boolean list. You can hover here on this pattern input and you see here a highlighted type Boolean array. So what we will do, we will use the parse JSON parse method to create this array. This is just fastest way to do that. There are other ways in bit by bit how you can create this sort of thing, but let's do it like that. So now I will create it like this, and I'll say that I want true, false, false, false. So this pattern will be taken and repeated across the wire, across the list of all the edges, and it will just filter out the things that we don't want. And let's do that. So I'll do it like this, and I'll do it like that. Let's hide this, and let's see. Yeah, so we hide this as well now, so we don't see anything. And let's just draw the result. So sometimes you see that now we filtered out the elements of this list of edges, and we have them, but we don't draw them because it's not really a draw command. This works on any types of lists. This is why this isn't being drawn, but we can just draw it with this component. And you see that now I only have the edges that I want to fillet by a variable fillet, and that's quite nice. So what I will do is okay, so now that we have it, we can remove these preview components, and I will just go into OpenCascade category, fillets, and I will look for 3D fillet for same variable radius. So I will fillet all the edges with the same variable radius. So let's then connect the edges that we've got into this component. Let's also connect the extrusion because this is the model that we want to fillet. And I want to now create two lists. So for radius list and params view. And I will also use this JSON parse command because it's just fastest way to do this. So this will be a radius list. So first radius will be 0.1. The other one will be 1.4, for example. Then we'll have 1.3, 1.4, and again 0.1. And let's just preview this data so that we know if we're on the good path. 0.1, 1.4, yeah, this looks okay. And I want to create another list for params. So params are like edge has the length, right? And it's a sort of unit length that we'll be using. So 0 means the start point, 0.5 means the middle point, and 1 means the end point of the edge. So we have like 5 radius items in the list. So for each of those, we'll say that there's a param on which this radius needs to be applied, and I'll do it like that. So 0.3, 0, 0.3, 0.5, 0.7, right? So let's be symmetric, and 1. These are the params that we will be applying, and let's just see how that looks like. This is looking okay. So now we will just connect the radius list and then params, and this component will compute. So now you see that we've created a variable fillet on all of these edges, and you see that it's taking this sort of wavy shape. This is quite complex geometry, but yeah, OpenCascade solves it really well, and it looks really nice. Okay, so in order to now apply the fillets on these edges on the top, we will need to get the wire from this upper face, and to do that we'll be using the extrusion itself to just say get face, and this requires an index, and the index of that face is actually the last face of all the faces. So what we will do is we will first get the faces, and we'll say hide. We'll measure the list length of this list, and you don't need to clone it, you can preview that. So what's the length of this list? Is 47, right? Okay, so we actually need the 46th item because the faces are measured from 0. So I will now compute that by using the math operation. You see here a lot of math functions. So I'll say that I want to subtract the first by second, and I'll use the subtract operation, and this will give me the 46 if all is good. So this is how you can do this in bit by bit, and I will say that I want to get the 46th face from this extruded shape, and also I want to get wire. I want to get the first wire indeed in this list. So this is again getting that wire that we will use to extract the edges. And to extract the edges, I'll use the same component here. I'll also use the same parse, and I'll use the same pattern components. So let's do that. Let's create the pattern. Let's copy paste this pattern here, and let's draw these edges. Let's see if that worked out. So you click on this component and you see that they turn green, and we see that we have the right edges now. So we have two lists actually. So if you preview them, you'll see that we have a list of shapes here, and also a list of shapes in here. So this is again two lists that need to be merged, and to merge these two lists I will first create one list which will contain two lists of items, and we do that like this, and look at that. So how it looks like is we have a list here, and you see that that sits in the list as well. So now we go down, and here's the marker that identifies that we are dealing now with two nested lists. And to unify those, what I will do is I will flatten them completely. So let's flatten them, and let's look how this flatten thing works. So now we flatten that with one layer, and that's still containing two lists, right? But if I flatten it one more time, now we're dealing with a flat list of items. The only thing is that they are all on the first level of the array, and this requires us to give it a list. That means that it has to be wrapped into a list again. So it's a bit of a play with those lists, but it's not too difficult. So you see here that now we have one list in this output, and it's all flat. And that's exactly what we want in this component. So now instead of providing only the bottom edges, we will provide this unified list of edges, and it will compute, and voila, now we've got this intricate shape. And what I want to do is I want to hide this top face that we've got here, because now it's intervening into our commands. Okay, so now it looks like we've hidden everything that we wanted, and this shape begins to look quite nice. So it's still red. We will apply the material a bit later. We still want to model this a little, so it's very simple. This part, we'll just use a chamfer edges command. So I'll just say, yeah, like that. And it's computing pretty fast, so no need to be over optimize this process. Now we've got it, and yeah, this is more or less what we had in the example video. So this shape begins to look quite intricate, right? And yeah, you also see that there are some shadows. These shadows come from directional light that we've created in the first iteration of components. So here we have directional light, here this one, and that creates all the shadows. So we can increase this to 6, for example. You see that lighting changes, and well, 3 is enough. Okay, so now we've got this shape. We had few texts on this shape, so what I will do is I will create that as well. We have a text thing under the advanced text 3D component, so I will create 3D text and I will put it on the point. So points and vectors are similar, or they work in the similar ways, and bit by bit. Yeah, we'll use it for the origin. So now it's up, and I'll say that it should be on Z -4, and that's good. I want to also make this bold and a little bit bigger, so 1.8 should be enough. Okay, so I have this. I will hide it, and I will get the compound shape of it, because at the end we will combine all those shapes into one single shape, and I don't want the default drawing command of this component to intervene in my drawing. So this is now a text on the top, and we had a text on the bottom, and it said WebCAD, so we'll use that. I will keep doing this one, and I will say that font size is 2. And for this component, we'll use a different coordinate for Z, so 4 and 4. And let's use that for the origin. And again, let's get the compound shape, and yeah, let's hide the original, and let's just leave the compound shape. So now we have our finished model, and the only thing left to do is make a compound of all the shapes, so of this chamfer of these two compounds. So you can go to OpenCascade Shapes Compound and create a compound, and you always see the actual function name here, make compound. So now I will just create a list of all the shapes that we want to put into the compound. So this one, and this one, and you'll see in a minute why I do that. So now I will hide this, I will hide that, I will hide this, and if I hide this one, then I hide everything, right? That's quite nice. So I will also hide these vector points so that they are not visible. And you see how I always go and I enable and disable things as I code, so that certain things become visible. It's just a good practice, because sometimes something can be hiding something important for you and you don't want that. So this is a way to go. And now when we have this shape, we can use a draw command to make it look a bit nicer. I don't know, I like this red, don't get me wrong, but to just make this metallic look, we can use Babylon material, that is PBR, so physically based rendering, and I will create this material, and I will use a draw command, so draw any async. You can also find that here, so draw async is what you're looking for, and I'll say that I want to draw it, and as long as you don't provide any options, you see that the draw produces exactly the same result as this make. But now we will say that we will use options, so we will choose this OCCT shape with material, and this component takes in the face material. So this is quite nice. We pass that in. There are also things like Z offset. So this is for edges to be rendered nicer. I'll show you how it works in just a minute. But now what we will do is we will just provide these options, and we'll see that the shape turned blue now. This is quite cool, but not exactly maybe what we wanted. So I'll make it a bit grayish, maybe bluish, grayish, like that. And I will increase the metallic part of it, and I will decrease the roughness. So now you see that because it's so smooth, metallic look just feels quite nice. And now you see the reflections of the environment on this shape as well. Okay, so we have now this shape, we've drawn it, and you can play around with this Z factor. This is exactly what I mentioned previously to you, that if you have it on 0, your face will intervene a little with the edges. So you see that now the edges disappear just a tiny bit because they are overlapped by the faces. But if we just use the Z offset, it's just a parameter on the material that allows you to render geometry a little bit nicer. You can also just choose not to render the edges here. So you can say, yeah, I don't want to render the edges, and see how the shape looks like without the edges. Still quite cool. I like it. You don't see the shadows very well with these reflective materials, but they're there. So you see here, there's a shadow marking. Yeah, so I hope you like this shape. Now the only thing left to do, I guess, is to just export this to something like a step file and STL file. So let's enable the edge drawing just for now. I will also export this file because we're finished with the modeling. And yeah, to export the shape, you will use the IO commands of OCCT. So you go here, you can choose what you want to do. You want to save the shape into the step or an STL. And so STL would go into CUDA software, for example, for slicing. And step file you can import into software packages such as FreeCAD or Rhino. So in order to control when you save the shape, you can use this value gate component from the logic category. So here we have this value gate, and you see that what it does is when this boolean is true, then the value gets passed. When it's false, it's not getting passed. So what you can do is you can plug your shape into the value and plug it in here, and then you see that now the file doesn't get saved, but when you click this button, then it gets saved. So the next time if you want to open the script and run it and you don't want the file to get saved, then you want to click this and be disabled, and that's how you control your files. So another thing to do is you can save this same shape into the STL, and let's use the same boolean. So now if I hit that, we'll save 2 files in one go. And you can click here, you can also control the precision, so how many triangles you want to save. So let's increase that to 001. So you should also probably adjust the Y and Z, because Babylon uses a different coordinate system, and to render it correctly in other software packages you should adjust those directions. And you can just hit again the bool and it will save the geometry. Takes a while, but okay. Okay, so now that it's done, we can disable it again, and we can open those files in third-party software. And I'll do that now. So I'll go to FreeCAD, and you see that I already opened it, so it looks quite nice. All the faces get imported, and FreeCAD uses the same geometry kernel as bit-by-bit dev, so that's quite nice. And also you can open the STL file. So here is the STL, and you can use that in CUDA or somewhere else. This is just Mac preview window. Okay guys, so this is it. I hope you enjoyed this video, and yeah, I hope you learned quite a few things about how OpenCascade can be used in bit-by-bit developers platform, how to use various kinds of categories together to create these models and visualizations. So this is quite nice. I'm happy about the result. I also hope that you're happy about this result as well. I hope that you've learned a few things. And yeah, if you like the videos, please subscribe, follow us on social media, join us on Discord where we can just chat live. I'm available there. And yeah, let's see each other in the next videos. Cheers, guys.